don't know that I really need that either, but okay. So that's that, and I will put it more like this. All right. So this is the first day of chapter 7. First day is sampling distributions. What we're starting to study in this chapter, honestly, is the whole reason that the topic of statistics even exists. It's because of how sampling distributions act. So the objective we're covering today is distinguishing between what a parameter is and what a statistic is. So this first part of the chapter is a lot of vocab. On page 3 of this packet, you have some empirical rule practice. You won't have one of these quizzes until next week sometime, probably Thursday or Friday. I'll probably give a couple of these. And if you don't have the numbers to write down, I'll try to do this next Tuesday. But they are also on, you should have them from before, but they're also going to be on the slides for today. Another thing I need you to do is by next Wednesday, so a week from today, I need you to get 25 pennies that are from current circulation, which means you have them in your pocket or in your car, or if your mom or dad have a place they drop their change, get it out of there. Don't go to Grandpa's coin collection and get pennies from like the 1970s or something. That's all. If you work somewhere and you can swap out 2 quarters for 50 pennies, that would be great. So I need you to do that because we'll do an activity with that probably towards the end of probably not until the last week of February sometime. All right, and we are going to measure how many inches we are today. If you have some shoes on with some height, you might gain an inch or 2. That's okay. All right. So the case study that this starts off with is about batteries. And basically, let's say Energizer or Duracell, you don't have this in your packet. Let's say we have a battery company who produces batteries, and they claim that each battery will last for 17 hours of use. So to test that theory or to test that claim, we take a random sample of 50 batteries, and we put them in a machine and see how long it lasts. And we get all of this data, 50 pieces of data. And from this 50 pieces of data, we're going to determine if the company is telling the truth or if they're lying. And that's what we're going to be doing this chapter, is from a sample, test a claim that about the population. Now, we just selected 50 batteries. Why can't we select all the batteries that Duracell makes to see if their claim of 17 hours is really true?
That's impossible.
Well, it's impossible. Why? There's a billion batteries. It would take lots and lots of money, time and money. But why else would it be ridiculous for us to test all the batteries that a company makes? Why is the company making the batteries? To sell them. And if we test them all, will there be any batteries left to sell? No. So this is really important. It's how the court cases, I think, was it Toyota was in trouble a few years ago about claiming their one car got 30 miles per gallon city. Actually, I think it might have been Honda. And so that claim was determined to be false. These are the statistics that are involved in that. So we do sampling because lots of times it's very impossible to test the whole population. All right. But that is kind of exactly what we've been studying up to this point. So if you turn to page 4, this is what we've been studying up to this point in the book, pretty much. It's descriptive statistics, which just means we take the data and we calculate the stuff, and we're not trying to make any predictions about a population. We're just trying to describe the data. So we have regular distributions, and you can add to this. We have regular distributions, and they have means, and they have standard deviations. And I guess I'm going to put this in a different color. It will be better for you to see. To calculate the mean, we just added up all the individuals and divided by n. And then we have a standard deviation, which is the square root of each data point minus the mean squared divided by n minus 1. And we kind of did this the other day. I just want to keep refreshing our memories. When we turn regular distribution into a probability distribution, which not all regular distributions go right to probability distributions, but if we do that, we have a new formula for the mean. It's the summation of each x sub I times its probability, and the standard deviation was the square root of the summation of each x sub I minus mu squared times its probability. And then we got even more specialized at the end of chapter 6. Binomial, if we know it's a binomial probability distribution, then we just do n times p, and the standard deviation is the square root of n times p times 1 minus p. If it's geometric, we do 1 over p, and we do the standard deviation is equal to the square root of 1 minus p over p. So that's where we just left, and we've been doing descriptive statistics, which is describing a data set. Sometimes they're normal distributions, in which case they give us the mean, and then we go out 1, 2, and 3 standard deviations. So this would be mu plus sigma, and this would be mu plus 2 sigmas, and so forth. And then we had bivariate data, which was chapter 3 with the least squares regression line, and we had y hat equals a plus bx, where b is the slope, and that's not what we learned in algebra class, but, and on Friday, we're going to do a statistical Valentine. Pretty cool, I have to confess. I wish I would have made it up, but I didn't. And I don't know if you guys remember this formula sheet. You got to use it on your test, and you hopefully have, I'm holding it in my hand. You guys remember this? If you have that and can find that for Friday, that would be helpful. I do have some, but I didn't plan on making a whole bunch more copies of it. So that's what's used here. All right. So this is where we've been. And now this is where we're going on the next page. If you take these distributions, and what I need you to put up the top of page 5, are we all done with this page though? On the top of page 5, I want you to put inferential statistics. So instead of just trying to describe the data we have, we're going to use the data to make a guess about a population. And so we're finally starting here, which is a good thing. And if everything goes smoothly, we'll be able to finish up inferential statistics before you take your AP test. I don't know if you guys were all notified. Does anybody know that the day of our test has changed? You're supposed to take it on Thursday the 13th, but we are now taking it on Monday the 17th. So I think, I don't know if seniors were let out yet. What is seniors' last day? Anybody know?
I think it's the 21st.
The 21st is your last day? All right. Well, we've moved from the 13th to the 17th. Or the 25th, but that's the day you guys graduate, so we're not taking the test then. Why did they change it? They didn't say initially. I don't know why. And I'm thinking, they just moved it because people were upset about taking a test on the 13th? Are people really that superstitious? I was a little bit flustered. But now the real reason is because that's the last day of Ramadan, which is a huge celebration and a huge religious day. And so they moved the test. Ramadan is something that moves throughout it's not the same time every year. So that's why it's never been a problem in the past. Okay, so this first picture is a little misleading because we can have populations that look like anything. So this first picture is a population distribution. So right here, this is a population distribution. And it can have all kinds of different looks. The reason statistics exist is because we don't know what the population looks like usually. But it's out there, we know it exists. And it also has what I usually refer to as your God knows, or God knows, the mean and the standard deviation. So mu sub x is the mean of this population. And sigma sub x is the standard deviation of the population. The other thing worth noting is each little block here, each data point, represents a single, I guess we'll say individual, a single data piece. So one height measurement, one tree diameter, one hours of how long one battery lasts, something like that. So what we do as statisticians is we dive into this population, which we usually don't know. We don't know what its mean is, and we don't know what its standard deviation is, and we usually don't even know what the picture is, but we go out to a population and randomly sample. So this next picture right here is one sample's distribution. This sample happens to be of sample size 5 because there's 1, 2, 3, 4, 5 little boxes. And so each little box here, each data point represents a single individual, just like in the population. But now we have a sample of size 5, so this is the sample size, little n is the sample size. Over here I should have added capital N is the population size. You have to be really specific with your notation, and if it's a capital N, make it a capital N. Don't get fancy with your own type of lettering and stuff like that, because that will definitely cause mistakes. The X bar is my sample mean, and S sub X is my sample standard deviation. And chapter 7 starts 7, 8, 9, and 10. These last chapters we're doing in this book It's all about inference. So it's all about these next things. So what we do is we take samples of size 5 over and over again from the population. And so then we drop into here. This has an X bar. We drop it into here. So right here, all of these little boxes, each data point represents a sample mean. All these blue dots are going to be little X bars. So they behave differently than individuals do. And that sleep sheep, the sheep sleep dash thing that we did, I have all the data that you guys gave me from your individual dashes and your average dashes. This guy right here has a very special name. So I should probably, this is the name of this, population distribution, one samples distribution. This right here is called a sampling distribution. Sampling distribution. Because it's not a distribution of individuals, it's, for this purpose, is a distribution of X bars. And that's really a different story, and it does some very nice things for us. And when somebody figured out, hey, sampling distributions do this, it allowed us to take from a population, form a sampling distribution, and then what we can do after we have the sampling distribution kind of figured out is we can make an inference about the population. So we can go back to the population. And here are the symbols for a sampling distribution. Mu sub X bar is the sampling distribution mean. I sometimes refer to it as the master mean. It is the mean of all the little means. And that's why it's mu sub X bar instead of mu sub X. And then we have sigma sub X bar. And we also get S sub X bar here eventually. And these are the standard deviation of the sampling distributions. And that ING is really super important. So what we're going to do today is practice all this little vocabulary. And then we'll come back to this picture over and over again. So this we really don't know. We take a sample, plop it into the sampling distribution, and we keep doing that over and over again until we build a theoretical sampling distribution, basically. And then we talk about how its statistics are associated and correlate with the population statistics. So that's where we've been, and that's where we're going. Woo-hoo. All right, so today is all about symbols and words and vocabulary. This is what I was talking about, taking a sample and going to a population. And here is what we need to remember for today. Statistics come from samples, S matches with S, and parameters come from populations. So on the top of page 6, we have this. Parameters are measures from the entire population. They have a population size of capital N. We have a symbol for the mean. That's mu sub X. There is no symbol for mode, median, or mid-range. There's no symbol for range or there is a symbol for variance. It's sigma squared. And the standard deviation is sigma. And those are both sub x's. There's no symbol for minimums and maximums. You just have to, you can write MIN and MAX. But other than that, there isn't any other shortcut symbol for min and max. All right. The other thing you need to know is that these two are in the quantitative world. That means you can put units on it. That means you can measure it. Measures of percent or population proportion, this is in the qualitative. It's also called the categorical world. And that's binomial. We just came from there. And population proportions have a symbol. It's rho. It's like a fancy P that's doesn't have any straight edges. You usually start at the bottom and go up and put the little P on. So to make this little symbol, you start at the bottom and just go up and around. Try not to make that with any straight lines. All right, so what do we have corresponding in statistics? Well, again, these first two measures of things are from the quantitative world, Q-U-A-N-T. And down below here, this is from the qualitative or categorical. And we have mean is X bar, variance is S squared, standard deviation is S, sample proportion is P hat, and it's a regular P with a straight line down, and then the hat means this is a predicted value, just like Y hat meant that Y was a predicted value for the when we did least squares regression. And then you're going to reference this page quite a bit, hopefully today. Maybe you already got this down. That would be great. The bottom part is just separating them into parameters and statistics. Capital N and little n are really not a statistic or a parameter. It's just the number of things in your population, which we usually don't know, and the number of things in our sample, which we have to know. But usually we don't call those statistics, so we're going to do something kind of a little different here. All right, we're going to practice on page 7, then you're going to do page 8 with a friend or neighbor, and we're basically done with the lesson then today. Woohoo! So what are we going to do after that? Well, I have to measure people, and you have bonus to do. Some of you have a test to finish. What else? I have some things to get back to you. Okay, so here we go with this. The Gallup poll asked a random sample of 515 U.S. adults whether or not they believe in ghosts. Of the respondents, 160 said yes. So the first thing I want to do with that 160 is 160 is actually a capital X. It's the count of people who said yes. But if we take X and divide it by N, does anybody remember what that equals? It was, I think, like the first thing in your notes. That's P hat, actually, I believe. So this is going to be 160 divided by 515. And I think that equals 0.3106, if I remember right. Yep. So we're just going to make it be 0.31. So there are two numbers. We have the number 515, And I'm going to use 0.31 instead of the 160. Because we should always turn the successful counts into a proportion. Okay, what do we call the 515? Does anybody know its letter or what it's called? Joe?
It's no sample size.
Yep.
So small.
Its little symbol is small n. This is called the sample size. And I'm going to have you write statistic. And then I'm going to have you put a line through it. Because it is a number from the sample, so it is in the statistics side of things. It's just you're not going to ever have a professor call that a statistic. I like to think of it as one because then it goes with all the sample stuff. All right, so I already gave you the symbol for this next one. That's a p hat. It's a statistic. And it is called a sample proportion. All right. During the winter months, the temperatures outside the Starnes' cabin in Colorado can stay well below freezing. So I'm going to put 32 degrees Fahrenheit as the first one. First number that I'm going to try to take care of here. For weeks at a time, to prevent the pipes from freezing, Mrs. Starnes sets the temperature at 50 degrees Fahrenheit. And I think I'll use a different color so that way you can tell I'm on a different problem. So this was 32 degrees Fahrenheit, 50 degrees Fahrenheit. She wants to know how low the temperature actually gets. So she gets a digital thermometer to record the indoor temperature 20 times randomly a day. And the minimum reading that it tells her is 38 degrees Fahrenheit. So this is, sometimes they're a little bit of a weird situation. I think the ones you're going to do next are less questionable. The 32 is actually an outdoor average. I'm going to call that a population mean, which is a parameter. And it would be a mu sub x technically. Now the 50 degrees is also the claim of what the indoor is supposed to be. So it's also a population mean, but it's for indoors. It's also a parameter. It's also a mu sub x, but it's a different mu sub x. We'd have to call it mu sub y or something if we were doing a problem with this. So those two, I think, I didn't want to call on anybody because those two were a little bit weird or unusual to understand. What's the 20?
Sample size?
20 is a sample size again. That's going to be an n. That's a statistic, not. I'm going to put the word statistic and cross it out because I don't want you to be thinking that it's really, I mean, it's a number that comes from the sample. It's just not, it's just counted up instead of calculated, I guess. So this is sample size. "38 degrees. Let's be careful on that. What is that? Who knows? Who's pretty confident that they know what that is? Yep. Is it a sample or population minimum? Yep. So it is a statistic, and it is a sample minimum. And this is what your homework is like tonight. Try to get good at this as quickly as possible because it's a skill you absolutely have to have for the rest of the inference course. We will have a little quiz sometime, not this week, next week. But on page 8, you have some to try yourself now. And just remember, if you're out in the hallway, you're social distancing. This didn't, I gave first block 10 minutes and they were done in like 6 or 7. So find somebody to work with. If you want to go out in the hall, now's your chance to get up and move. We'll go over this and then we'll let people get to doing what they need to be doing. And I'm going to go check on Hannah. I'm going to pause this. Soon. So that's what we'll be doing, and you can start your homework. The helpful hints are out there if you don't have your book. Okay, first one is 20. And of course I pulled the one person who's not in the room. Joe, what did you say 20 was?
Population mean, parameter, and mu sub x.
Yep, if you just put a mu, that's okay, but mu sub x is better. All right, the next number, sorry, I know you guys are still out there. You guys finished?
Yeah.
Okay, the next number is a 50, and Miss Currington.
We said sample size.
Yep.
Statistic not.
Yep.
Symbol is N. Logic.
Yep, and I'm just having you cross this out because I want you to sort of think of it as a statistic, even though nobody else calls it that, but it is on the statistics side of things because it's with the sample. All right, Alexis, the 19.6.
Sample mean, statistics, and bars.
Yep, an X bar. Yep. All right. Any questions so far? New York to Denver flight, 8% of the 125 passengers were selected for random security screening. According to the Transportation Security Administration, 10% of passengers at this airport are chosen for random screening. All right, Nick Borat, what do you get for the 8%?
I said sample proportion, statistic, and p-hat.
Yep, sample proportion, statistic, and p-hat. Excellent, the 125, Mr. Kale.
Sample size, statistic,
And very good. And the 10%, Ainsley?
Sample proportion, statistic, and then a half.
Well, it's technically talking about all the people at the airport. So I'm going to call it a sample proportion or a parameter or the row, the MCP. If you're thinking of the airport as a sample of the population of all people at airports, then I could go with sample proportion. But we're going to make it the parameter because it's talking about everybody at the airport. All right, next one down. And this is, I have this right here. Pediatrician wants to know the 75th percentile for the distribution of heights of 10-year-old boys. So she takes a sample of 50 patients and calculates the 75th percentile in the sample is 56 inches. Allison, what do we get for the 50?
Sample size, statistic not, and little n.
Yep. And Leah for the 56 inches.
Either the third quartile, statistic, and the two-thirds.
Yes, it is a third, it's a sample third quartile, it's a statistic, it's Q3. A Pew Research Center poll asked 1,102 12 to 17-year-olds in the United States if they had a cell phone. 71 of the respondents, 71% said yes. Caden, what's the 1,102?
sample size,
Yep,
statistic, and
yep. And the 71, Amelia?
Sample proportion, statistic, and not.
Yep. Okay, and And the last one, the Bureau of Labor and Statistics last month interviewed 60,000 members of the U.S. labor force, of whom 7.2 were unemployed. Mr. Paula?
Sample size,
Yep,
statistic not, and delay.
yep. And then the 7.2. Other Nick?
Sample proportion, statistic, and feedback.
Yep. All right, any questions? Usually you're doing sample proportion, sample means, population means, but occasionally they'll throw a strange one in there. And you have this sheet to fill out tonight. If you don't have a textbook, you don't want to take your textbook home, then this is what I have set up for you. I have the prompts, and initially, the directions in the book ask you to identify the population and the parameter of the population and the sample and the statistic. So that's what this is doing. It helps you fill out that table a little bit if you need help. But eventually, as we go on, you can see that I have stuff whited out. But the prompts are still there, so you can still read the question. Like for number 3, you're doing those 3 numbers, and I have whether they're statistics or parameters if you need help. But at least you can read the prompt if needed, and then we go down to the last one. So we have to be really, like this has to be extremely quick for us eventually. There shouldn't be any questions about whether it's a statistic or parameter. In a month or so, we should be able to do this very fast.
What page is this on in the textbook?
In your textbook, it is page 436. And there are textbooks right behind Joe in the shelf. And you can just fill this out on your sheet. All right, so I need to take, you guys can have your purple sheets out, but please have your phones stored somewhere. I think Valerie is who I will. Okay, Ainsley, you were just needing, you have the last 3, right?
Yeah.
And Chelsea, you were done with the first page? Okay, and Elena, I have yours. And, all right. Thank you. All right. So Valerie, why don't you bring your stuff and come with me? And Elena, if you move over to Valerie's seat, because I need that one for, yeah, go ahead and take all your stuff. Valerie, you can bring all your stuff. All right. All right. And Ainsley, and I have this tile for grading, so just ignore the pink. Put your, and I'll regrade. All right, is there anybody else that didn't finish up something from the test yesterday? Joe?
I just had that last thing.
Oh, okay, let me get that for you. And then I'll give the rest of you, if you wish, to try the, bonus. And when you're done with the bonus, I will take it back from you and, all right. You gotta show work though if you're gonna get any bonus points for it.
What did I use?
Yep. Yes, you are allowed to do the first one.